Is it possible for the starters given to you at the beginning of Cassette Beasts to be bootlegs? The initial answer seems to be no, but with a bit of clever math, we can exploit the random number generator to achieve the impossible.
Hey! Yeah! Yeah!
So far, at least 3 seeds have been known to give bootleg starters. If you're only interested in the seeds, I've included them in the description below. Start a custom game mode and input any of these numbers as the random seed. This affects the starters as well as the free Congruential tape given at the end of Felix's quest.
Oh.
No!
Thanks.
Farewell!
If monsters are randomized, they're still treated as astral bootlegs. For the rest of the video, we'll be covering the code and math that led to the discovery of the seeds, as well as some of the consequences these special seeds exhibit. We'll be starting with a decompiled copy of Cassette Beasts version 1.2 opened in Godot engine. The starter choice is stored in this Choose Starter menu scene, which currently has both Banship and Candevil in an array for the starter options. Whatever starter is chosen gets passed along later on. This Choose Starter menu scene is loaded by something else, and if we follow this chain we eventually end up with this cutscene. Here we see our target, the Give Tape action node. Looking at its variables, the bootleg rate is set to 0. It is reasonable to look at this and conclude that they can never be bootlegs. The seed key variable just below it is blank, which will come into play later once we start searching for the bootleg starter seeds. The Give Tape action node is a generic node that is used 4 other times, and in all those times the bootleg rate is either 0 for the starters and the Congruential tape, or 1 for the West Harbor Town bootleg and the Ranger Outpost reward. The ready function in this script contains a lot of code that are not relevant, so we can strip it down and rewrite it as such. Here, rand is initialized as a random number generator whose seed is given in this argument here, which we'll get to in a moment. For now, we can just replace this with a variable named seed value. Make bootleg is just some code that is executed only if this conditional statement is true. For our case, bootleg rate is 0, so this reduces as such. Alright, time to investigate what this randbool actually means. This is a function from the random class which handles most of the RNG needed by the game. First chasing randbool, we find that in our case true chance is set to the float 0, which is neither null nor rational. The assertion just makes sure that it's not being passed a weird variable type, so we can just gloss over that. The argument passed here is 0, so the function returns either true or false based on if rand float is less than 0. Now we need to check this rand float function, which is fairly short. The modulus in this script is set to this value here, which simplifies to 2 to the 31 minus 1. This calls another function in the script, randint. Coming from rand float, we do not pass any argument, so max value is null by default. This leaves us with this stripped down version of the function. Finally, we look at this LCG function, which is a linear congruential generator or LCG shown here. Okay, we just went through a lot there. Fortunately, this is our last step. If we can find a way to manipulate this LCG, we can force the game to do the impossible and give us the bootleg starters. But before we can do that, I want to cover the basics of linear congruential generators so we can understand how we can get what we want. If you're already familiar with them, we can skip ahead to the timestamp shown in the video. At its core, linear congruential generators take on the general form x sub n plus 1 equals a times x sub n plus b, and all that modulo m, where a is the multiplier, b is the increment, and m is the modulus. This modulo operator means that we divide this term here by m and take the remainder of the operation. In programming, such as Godot's own GD script, this modulo operator is represented with a % symbol, but we will be using mod for the remainder of this section. Wikipedia gives a nice practical example to think about this, which is a 12-hour clock, though we'll change the 12 o'clock to 0 o'clock for actual modular arithmetic. Suppose that the hour hand is currently pointing at 11. If we add 2 hours to it, the time reads 1, even though 11 plus 2 equals 13. In this case, we say that 13 mod 12 equals 1. Equivalently, thinking of it as getting the remainder, 13 by 12 gives a remainder of 1, which also means that 13 mod 12 equals 1. For this example, 13 is congruent to 1 mod 12, meaning that under this modular operation, 13 is identical to 1. Returning to our LCG, x0 is the starting seed, and when we need a random number, this LCG will multiply our seed x0 by a, then add b to it, and take that modulo m. The result is x sub 1, which is the random number given to us by the LCG. After that, x sub 1 becomes the new seed for the LCG, so if we need another random number x sub 2, the LCG will perform the same calculation but this time using x sub 1 instead of x0. The results of the LCG are deterministic, which means that even though its outputs look completely random, if we could somehow recover the seed initially used by an LCG, we can predict any future values it will give us. Getting back on topic, Cassette Beasts use the following constants. As for why these constants, it turns out that this choice gives us the so-called minimal standard LCG, first conceived to take full advantage of the 32 bits used by IBM computers. The multiplier was chosen so that this LCG can produce any value from 1 up to 1 less than the modulus before repeating any values in a cycle, which can only happen if the multiplier and modulus are relatively prime, meaning they don't share a factor. This LCG breaks when we use a seed of 0 or, in general, any integer multiple p of the modulus, since x sub n equals 0 every single time. In that case, we end up with a degenerate RNG which produces the same result, which is not desirable for producing pseudo-random numbers, but it is precisely what we need to break the game's RNG and force it to do the impossible. As previously mentioned, this LCG will break and give a degenerate result if the seed value happened to be congruent to the modulus. That is, the seed value is an integer multiple of 2 raised to 31 minus 1. Now our LCG only produces 32-bit unsigned integers from 0 up to 2 raised to 31 minus 2. However, this LCG function accepts an int argument, and looking at Godot's documentation, int is a 64-bit integer whose values can be in the range negative 2 raised to 63 up to 2 raised to 63 minus 1. This allows us to pass an integer multiple of the modulus and force a degenerate case for the LCG. Recall that we went along this chain of functions since the bootleg check calls for randbool of 0. With an LCG that always returns 0, randint becomes negative 1 even though it is normally non-negative. Evaluating randfloat gives us a small but negative number, which is less than 0, so randbool evaluates to 2 and we get our bootleg. Note that this is only possible when we choose such a seed value. For any other seed, randbool of 0 would output false. So it is possible to break the RNG, but we have some extra work to do since it's not directly seeded by our save file's random seed. Returning to give tape action, the first line in run creates an RNG with a seed involving the child seed function. The last line is simply h times 2 to the 16 or 65536 and then XOR it with seed value. If you're not familiar with this operator, XOR, short for exclusive OR, is a bitwise operation that returns 1 if the corresponding input bits are different and 0 otherwise. For both the starters and the Kuniko tape, seed key is an empty string which is then hashed into an unsigned 32-bit integer. The output of the hash is based on the characters on the string input, and it turns out that hashing an empty string produces 5381. So whatever this result is ends up being the seed for the RNG. We just have to solve the following equation and then we're done. Fortunately, the inverse of the XOR is itself, so we can just get seed value as such. This can be simplified to be any integer multiple of the modulus XORed with this number. For instance, if we pick the following integers, we get seeds that all give bootleg starters. Since integers in Godot have 64 bits, we can expect about 2 to the 32 seeds that also satisfy this condition, but a custom seed input only has a 10 character limit, so for now we're stuck with these 3 seeds. Incidentally, the RNG used in give-tape action also controls the bootleg typing, and since these special seeds force the LCG to always spit out 0, we expect them to all be bootlegs of the same type, which happens to be Astral. Astral isn't the 0 index, but what ends up happening is randint is called, which is -1, but in modulo 14 gives 1, and Astral is the second type on the list alphabetically. As an aside, this only affects one of the starter tapes given as a Ranger notice board reward. If your starter was Candevil, the Banship will not be an Astral bootleg since the seed key isn't blank. And that's it. That covers everything about the Bootleg Starter Seeds. But that lends itself to the next question. What else can be exploited in the same way? Unfortunately, the restriction on acceptable seed severely restricts what can be done in vanilla. We could for instance have control over the item rand seed by using the hash of items instead of blank, but after passing it to a child seed, there are no 32-bit seeds that would yield the desired outcome. If this could be done, the vending machine will give the same sticker for the day, and even the uncommons have the exact same attribute. We could even do the same with passive quest rand and get rather interesting spawns. If you've made it to the end of the video, I just want to say thank you for watching. This video has been in development for almost 3 months now. All bootleg starter seeds were found right around August 7, and I have gotten busy with life since their discovery. I'm still not sure if this type of content is a one-off thing, but regardless, I hope you enjoyed this explainer video.